Good morning, good afternoon, good evening, or however time is when you will be watching this video, guys. Welcome to another video. It has been a while since I haven't uploaded another video. So the topic for today is the real number system. We are trying to get to the calculus topic, but everybody know, in order to see the calculus, the basis is the real number system. For those who would like to know, I will be using material for the algebra and trigonometry, graphic models for addition by Beecher, Allen, Bogan, and Pena. So that's one calculus book that is used over here in the USA, and this book, I like this book because it has a pretty easy approach, and actually the first topic is the real number system. It is always a good idea to do a little review before we actually start with the calculus. The real number system. So the first set of numbers of the real number system is the natural numbers. And the natural numbers are represented by a letter N, and the first element of the natural number is 1, 2, 3, all the way to the infinite. So any example of the natural numbers is any number that starts from 1 all the way to the infinite. Another set of the real numbers is the whole numbers. The whole numbers we could represent it by n with a small 0 next to the n. And what I mean with this, you see what we represent over here. So the first element of the whole numbers is 0, then 1, 2, 3, all the way to the infinite. So we can see the natural numbers are included on the whole numbers. What's the difference between the natural numbers and the whole numbers? Well, the difference is that the whole numbers include the 0, right? And the next set of numbers in the real number system is the integers. The integers are represented by a letter C, and the integers comes from the minus infinite and it goes all the way to the infinite. So basically all the negative numbers plus 0 plus the positive numbers. That's the set of the integer numbers, right? Again, you can also see that the whole numbers are included in the integer numbers. So now let's jump to the next set of numbers, which is the rational numbers. And the rational numbers are represented by a letter Q. Let me mention something. So I'm from El Salvador, and in El Salvador we represent the rational numbers by a letter Q. I haven't seen that in this textbook that I mentioned earlier, the representation for the rational number, but in this video, let's represent it by a letter Q. Okay? So in the rational numbers, what are the rational numbers? Irrational numbers are numbers that can be expressed in the form P over Q, where P and Q are integers and Q is different than 0. So irrational numbers, they are fractions, and they are numbers in the form P over Q, right? In which P and Q are integers. They both are integers, right? And Q is different than 0, right? Also, another characteristic about the rational numbers is that decimal notation for rational numbers either terminates or repeats. So we have some examples of the rational numbers. 0. 0 is in the form P over Q. Why? Because if we put as denominator 1, we're still gonna have 0. 0 divided by 1, still gonna be 0. Minus 7 is another rational number in the same situation. And you could say, why minus 7? This is not a fraction. This is only one integer. Yes, but if we put as denominator 1, then we have an integer, a rational number in the form P over Q, in which Q is different than 0, which is, in this case, is 1, and 1 is different than 0. And we all know that minus 7 divided by 1 is minus 7. Another example of rational number is 1 over 4, in which his decimal part is 0.25. That is a rational number because it is on the form P over Q, and then his decimal part terminate into 2 decimal after 0. Another example of rational number is minus 5 divided by 11. Why? Because his decimal part is 0.45454545, so on, all the way to the infinite. So instead of writing all the numbers to the infinite, we can represent all the infinite decimal as 0.45 with a little curve on top or a straight line. Here in the USA, it's usually a straight line. I like more the little curve as I learned back in my home country. Okay? All right, and then we could also, mention another rational number, which is 3/2, which is 1.5. This is a rational number, which it is in the form P over Q, and Q is different than 0. 3/2, and the denominator, in this case, is different than 0. We can also mention another example of rational number, which is 6.15, 6.15, 15, so on. So this one can be expressed as 6.15 with a little symbol on top of the decimals. Now let's jump to the irrational numbers. The irrational numbers can be, again, right here, on this textbook, they represent it by a letter I. However, in my culture, the imaginary numbers, which is another topic away from what we checking today,